Welcome back to DevOps Ascent. In this lesson, we tackle the question, your nginx pods are happily running, but how does anything actually reach them? The answer is Kubernetes Services. Let us climb. Here's the problem. Pod IPs are ephemeral. Delete a pod, a new pod appears, and it gets a brand new IP address. Nothing stays stable. You have 3 replicas running. Which one is the app? Clients should not care. They should not have to track individual pod IPs. We need load balancing. And your app containers need to talk to each other. By name, like Redis and Docker Compose. Not by floor-swapped IPs that change every 5 minutes. The insight is this. Pods come and go, but the app is permanent. So Kubernetes gives the app a stable identity. A service. A fixed name and a fixed IP that stands in front of the label selected pods and load balances across them. Here is the anatomy of a service. 3 concepts, no more. The selector, which is the label predicate. The port, which is the door clients connect to. And the target port, which is the actual container port behind the door. Think of the service as a doorman at a desk. You type port 80 at the reception desk. The doorman checks the selector list and hands the request to one of the pods. Pods rotate every call. There are 3 service types you need to know. Cluster IP, the default, is internal only, reachable only inside the cluster. Node port exposes the service on a high port on every node, good for dev and kind demos. And load balancer hands the service to the cloud provider's actual load balancer. That is how the internet gets to your app in the cloud. Here is the ladder to remember. Cluster IP, node port, load balancer, and ingress. You will stack the whole thing in later lessons. Ingress is lesson 5. Time to try it. Save your web service YAML, apply it, then check the service. Note the cluster IP and the web name. Then look at endpoints to see the live list of pod IPs behind the door. Now for the magic moment. Kubernetes runs a DNS service called core DNS. Everywhere in the cluster, a pod can resolve the name web. Exec into any web pod and hit http://web. That request hits a random backend of the 3. DNS resolve the name, and the service load balance the request to a selected pod. Endpoints are the live list of pod IPs behind the service. The resurrection complement. Delete a pod, and the endpoint list changes in seconds. Pods are selected by labels. Dead pods leave the list before they are recreated. Scale your deployment from 3 replicas to 5. Check endpoints. Now 5 IPs. Scale back down to 3. The list shrinks again. Watch it live, and the whole cluster stays consistent. Your exercise. Save web service YAML, apply it, and capture the service and endpoints output. Get a shell inside one pod and curl HTTP to web. Prove it can reach the app by name across instances. Scale 3 to 5 to 3 and capture endpoints at each stop. Kill a web pod mid-scale and correlate the endpoint list change. Prove it. Why can we not use pods directly? And what is a service fixed by abstraction? What exactly backs a service? And why does it stay fresh? For an app that talks to its own database, what do you declare so the name resolves? And what is the difference between port and target port? That last one is the interview favorite. Here is what you learned. Pod IPs are ephemeral. The service is the stable door. Selector picks the pods. Port is the door. Target port is the actual container port. 3 types: cluster IP, node port, load balancer. And DNS makes it all reachable by name. Next lesson, labels, selectors, and namespaces. The addressing spine of the cluster.